Welcome back, guys, to the second part of section 8-1, identifying quadratic function. Guys, sometimes you can identify the opening direction of the parabola even without graphing. If you look at the standard equation of a parabola, if you look at the number or the coefficient in front of x squared, this a, it gives us an idea about the opening direction of the parabola, whether the parabola opens upward or downward. How do we know? If the value of a is positive, if it's greater than 0, the parabola opens upward. It's a happy face parabola like this one. And if a is a negative number less than 0, the parabola opens downward. It's a sad face parabola like that one. Take this example. Tell whether the graph of the quadratic function opens upward or downward and explain. Guys, we're not gonna graph the quadratic function. We're just gonna find the coefficient of x squared in order to determine whether the parabola opens upward or downward. Guys, this equation is not written in the standard form, so before you determine the opening direction, you need to write this equation in the standard form. You need to isolate the y. So let me add the opposite of negative 1/3 x squared, which is plus 1/3 x squared to both sides, and write the quadratic equation in the standard form. These two terms cross out each other, so y is equal to, remember guys, when you write the equation it has to be in the standard form, so you write the x powers in descending order from the largest one, which is 1/3 x squared, to the least one, plus x minus 3. Guys, our concern in order to know the direction, the opening direction, is that number only, 1/3. Because 1/3, a equals 1/3, and this 1/3 is greater than 0, it's a positive number. Yes, it's a tiny fraction, but still positive number. So this parabola opens upward. So it's a happy face parabola like that. Take this part. Y equals 5x minus 3x squared. We're lucky this time because y is isolated, but the other part is not written in the standard form. Guys, remember the standard form, y equals, everything is written in descending order, so you need to start with negative 3x squared plus 5x. Just rewrite the equation in a standard form. Guys, how do I know the opening direction of this parabola, whether it's upward or downward? From that number in front of x squared. This time a equals negative 3, and the negative 3 is a negative number. Definitely it's less than 0, so the opening direction of this parabola is this way. It's gonna be a sad face parabola. So guys, the parabola opens downward. This time it's downward. Very easy. The second skill you need to learn today, guys, it's minimum and maximum values. If the parabola opens upward like this, the vertex is the least point of the graph. It's the minimum point of the graph. And the y-coordinate of the vertex, this 0 is the y-coordinate of the vertex, is called a minimum value of y. This is the least y value you would ever find in this situation. The opposite if the parabola is downward. If the parabola is downward, the vertex is on the top of this graph. It's the highest point, and the y-coordinate 5 in this situation is called a maximum y value. This is the maximum y value you would ever see in this parabola. So identifying a minimum and a maximum values are pretty cool, pretty easy. Take example number 4. Identify the vertex. We need to read the coordinates of the vertex. This is the vertex of this graph. Later, we need to give the minimum or maximum value of the function. Okay, guys, let's start with identifying the coordinates. The x-coordinate of this vertex reads negative 1, 2, 3. It's negative 3. And the y-coordinate is 2 units above the x-axis, so it's negative 3 and 2. Is it minimum y value or maximum y value? We're looking for this value, guys, the 2. It's minimum. Why it's minimum? Because the parabola opens upward, and this vertex is the minimum point, is the least point, so it's minimum 2. It's gonna be minimum 2. In part B, the opening direction of this parabola is downward, so the vertex is in the top, so I expect a maximum y value. So guys, the vertex coordinates are 2 and 5. 2 and 5. My concern is this 5, because the parabola opens downward, it's a maximum 5. So it's a maximum. Sometimes it's minimum, sometimes it's maximum. It depends on the opening direction of the parabola. The last skill you need to learn today, guys, is to find the domain and the range of a quadratic function. Let me start with explaining the meaning of the domain and the range. Guys, domain of any function, it means all allowable x values or input values. The input values. And when you talk about the range, you're talking about all allowable or possible y values or the output values. The output values. Guys, we normally use capital D when we talk about the domain, and we use capital R when we talk about the range. The domain of any quadratic function is always all real numbers. All real numbers. If you remember, guys, when we graph quadratic functions, we represent some negative values and some positive values, and you can choose any value, even the 0. So the domain is all allowable input value, and it's all real numbers. Any real number can be used as input of a quadratic function. But what about the range? The range is quite different, and we get the range from the graph of the quadratic function. Guys, if you notice, the parabola opens downward, and the vertex coordinates are 1, 2, 3, 4, 5 units to the left, it's -5, and 1, 2, 3 units down, so it's -3. And this -3, guys, it's a maximum value because it's the highest point, because the parabola opens downward. So guys, what are the possible y values? The possible y values, the maximum y value you ever see is -3, and all y values are going down. The y values are going down. So the maximum y value is -3. So the range of this value, any y value that is less than or equal -3. You might see -3 or any value less than -3. Of course, the situation gonna be different if this parabola opens upward. You're gonna replace this inequality symbol, and instead of less than, it's gonna be greater than or equal the same minimum value. Study well. See you in next lesson. Bye, guys.